Hello guys, welcome to the video. In this video, I will be solving questions 8 to 15 from second chapter. So let's get started. The first question is to find the complement of f, and we should show that f dash equal to 0 and f plus f dash equal to 1. So let me write f equal to wx plus yz, and f dash will be wx plus yz the whole bar, and using De Morgan's theorem we will have wx over bar yz over bar. Again using De Morgan's theorem we will have this. Now f into f dash is wx plus yz multiplied by w bar plus x bar multiplied by y bar plus z bar. So we will have w bar x plus w x bar x plus y is w bar plus y is x bar whole multiplied by y is y bar plus z bar, and this will be 0, this will be 0. Then if we multiply this, y bar z w bar plus y z z bar w bar plus y bar z x bar plus y z z bar x bar. So y bar 0, z bar 0, again y bar 0 and z bar 0. So everything will be 0. So we have proved that. And similarly, f plus f dash equal to 0, we can also equal to 1. We can also prove this, but I will just write it like this. Yes, whole bar. So let's take this as 1. So this will be 1 plus 0. Or if this is 0, then it will be 0. Both will give the answer 1. So that proves this. And let's go to the next question. Okay, again we should find the complement of the following expressions. Okay, a is x y bar plus x bar y. This is XOR gate and complement will be XOR. But we can also prove it x bar y the whole bar taking De Morgan's theorem multiplied by, then again taking De Morgan's theorem we will have x bar plus y bar whole bar y into x bar is x plus y bar. Multiplying it inside, x bar will be 0, we have x bar y bar xy and y bar will be 0. So this is nothing but NOR gate. A B a plus c into a plus b bar into a bar plus b plus c bar. Okay, taking complement we will have De Morgan's theorem and it will be a plus c the whole bar plus a plus b bar whole bar plus a bar plus b plus c bar the whole bar. Again taking De Morgan's theorem it will be a bar into c bar plus a bar into b plus a into b bar into c. So this will be our final answer. And the last question is z plus z bar into b bar w plus xy. So taking complement we will have z bar multiplied by z bar into b bar w plus xy whole bar. Taking the margins again, we'll have z bar plus b bar w plus xy whole bar. Taking the margins again, z bar into z bar plus b bar w whole bar multiplied by xy the whole bar. Again taking the margins, we'll have z bar into z bar plus b bar, sorry, it will be b into b plus w bar multiplied by x bar plus y bar. So this will be the final answer. Okay, so that concludes this question. Let's move on to the next question. Okay, given the Boolean functions f1 and f2, show that f1 and f2 contains the sum of minterms of. Okay, they didn't mention how many variables, so let us take f1 as a 2 variable and let us take it as AND gate, and let's take f2 as OR gate. Now we will draw the truth table 0 0 0 1 1 0 1 1. f1 will be 0 0 0 1 and f2 will be 0 1 1 1. Okay, now we have E equal to f1 plus f2, so it will be 0 1 1 1, and G equal to f1 f2, it will be 0 0 0 1. So we should prove E contains the sum of minterms of f1 and f2. So first we should find the minterms of f1. Minterms of f1 are only 3, and for f2 the minterms are 1 2 and 3. Minterms are the terms where we will have an input aside. So for example in f1 this is 0 1 0 1 2 3, right? So for f1 at 3 we have a 1, and for f2 at 1 2 3 we have a. So for f1 the minterm is 3, and for f2 the minterms are 1 2 and 3. Similarly for E the minterms are 1 2 3. So you can see it contains the minterms in both f1 and f2. So we have proved A, and B is G's minterm is only 3. See here, only 3. So G contains only the minterms that are common to f1 and f2. So common to f1 and f2 is 3. So G only contains 3. So both these statements are proved. You can take any example. I have taken a simple example. So that concludes this question. So let's move on to the next question. List the truth table of a function. Okay, we should just draw the truth table of these two functions. We have x, y, and we will have a y bar. Then we have xy bar. Finally we have xy plus xy bar. So this is 0 0 0 1 1 0 1 1. This will be 1 0 1 0. X y will be 0 0 0 1. X y bar will be 0 0 1 0, and adding these two will be 0 0 1 1. So this is A, and B is, we have A, B, C, and we are also having A bar, C bar. We have BC, then we have A bar, C bar. Finally we have BC plus A bar, C bar. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. A bar will be 1 1 1 0 0 0 0. C bar will be 1 0 1 0 1 0 1 0. E into C will be 0 0 0 1 0 0 0 1. A bar C bar is 1 0 1 0 0 0 0 0. So adding these two, we will get 1 0 1 1 0 0 0 and 1. So this is the truth table for this question. So let's move on to the next question. Okay, we can perform logical operation on strings of bits by considering each pair of corresponding bits separately. Okay, given two strings A and B, evaluate the result. Okay, so we have given A is 1 0 1 1. Okay, right in the middle. So given A equal to 1 0 double 1 triple 0 1 and B is 1 0 1 0 double 1 double 0. So first one is AND gate. We should do bitwise operation. That means we should do operation for individual bits. Okay, for example, first question AND. So first bit is 1 1 1 1 will be 1 0 0 0 1 1 0 0 0 0 1 1. So B is OR gate. OR will be 1 0 1 1 1 1 0 1. Next it will be XOR. XOR is odd one detectors. When there is odd number of ones, the output will be high. So 1 1 1 0 1. Then we have not A, the just invert A. So 0 1 double 0 triple 1 0. Finally we have not B, just invert B. 0 1 0 1 double 0 double 1. So that concludes this question. Let's move on to the next question. Okay, this is an interesting question. So what we should do is draw the logical diagram to implement the Boolean functions. Okay. So that concludes this question. Let's move on to the next question. Okay, the next question. This question is one interesting question. We should draw the logic diagram with the different gates mentioned. So let's take x yx plus y bar x bar plus y bar z. So first option is using AND, OR and inverter gates. So xy and x bar, y bar, then we have y bar z. Then we can just OR all these together. Then we have the output. Yeah. Okay, this is simple, but now it gets a little tricky with OR and inverter gates. So How can you AND with OR? So here we will use De Morgan's theorem. So we will take xy, we will invert them, and we will OR them. X bar, y bar, and again we will invert them. So this will be x bar plus y bar the whole bar, and if you apply De Morgan's, it will be xy. Okay. Similarly, we will OR x plus y, then we will do inversion, then this will be x plus y the whole bar, which is equal to x bar y bar. Finally, we will take y and we will invert z. We will use OR gate here under inverter gate. Here we will have, after applying the Morgan's, we will have y bar and z. So we got the three desired terms. Now we will just OR all these terms. Similarly for all the other questions. So that's it for this question. Let's move on to the next question. So this is the final question on this video. Simplify the following Boolean function t1 and t2 to a minimum number of literals. Okay. From the truth table we can see that t1 is complement of t2. Okay. First let's write t1 in terms of it will be 0, 1 and 2, and t2 will be 3, 4, 5, 6 and so on. So we should minimize them to a minimum number of elements. So t1 is a bar b bar c bar plus a bar b bar c plus a bar b c bar. So we can take a bar b bar common from these two, then we have c bar plus c, which is 1, then finally we have a bar b bar plus a bar b c bar. So now we can take a bar common, so it will be a bar into b bar plus b c bar, and b bar plus b c bar we should use a distributive law, then it will become a bar plus c bar. So a bar into b bar plus c bar. This is t1. So similarly t2 will be a little lengthier, but okay. So it will be a bar bc plus a b bar c bar plus a b bar c plus a b c bar plus a b c. So we can take a b bar common from these two and a b common from these two. So a b bar, if you take a b bar common from these two, we will have c bar plus c, which is 1. Finally we will have a b bar. Similarly, a b common from these two, we will have c bar plus c, and finally we will have a b. Now what we can do is take a common from these two terms. We have b bar plus b, which is 1, so we will have a bar b c plus a, So again we can use distributive law. It will be A plus BC. Okay. So now we can also prove that T1 equal to T2 bar. It's unnecessary, but we can just prove it. So T2 is A plus BC. The whole bar will give, applying De Morgan's theorem, A bar into BC the whole bar, which is A bar into B bar plus B bar, which is T1. Thus we have proved. So that's all for this video. Let's meet on the next video. Thanks for watching.